Let me just test the clicker here. All right. So quick introduction. As Jeff said, right now my primary identity is as a blogger and a consultant. Before that, I started doing this full-time about a year ago. Before that, I spent about a decade working for a startup. I was working at Xerox for about 4.5 years. I have a PhD in aerospace engineering, so I have several years in academia as well. And at Xerox, I was an entrepreneur in residence, and I was responsible for launching a couple of new products from the research division. So that's my rough background, but this talk is more with my blogger, writer hat on. And as a blogger and writer, my interests revolve around things like business history, long-term history of like American competitiveness, things like that. So that's the perspective from which I'm going to come at this talk. So the talk is going to be about mainly the competing on code side. The breathing data, I put that up there because it's a very important piece of subtext for me that underlies all my thinking here. And it's a very major research focus for me in the next few months. I'm starting a major project on data. That's why I put up the big data on the whiteboard over there. So just taking a little unfair advantage of my position here to promote my own little topic there. Okay, so what do I mean by competing on code? It's easiest to understand this if you look back at American business history and look at various sources of competitive advantage. So in the 19th century, for example, at various points, American competitive advantage could be attributed to strength in things like railroads, oil refining, various other things. And one very important phase was between about 1870 to 1900, where American competitive advantage depended primarily on precision manufacturing. And Chicago actually was one of the places where some of the action happened. So in 1851, there was this, in London, there was something called the Crystal Hall Grand Exhibition. And International Harvester from here in Chicago went there, and they won a gold medal. And what made America really competitive at that point was it was the only country that really could do precision manufacturing at a level of interchangeable parts. Like all the other old European industrial economies were good at manufacturing, and they had gotten engineering up to quite sophisticated levels, but they were not able to get to the point of interchangeable parts. And that was an American innovation. Fast forward about 150 years, today we are at a point where everybody's favorite whipping boy for why America is not competitive is this idea that we treat everybody as replaceable and interchangeable, including people. So that's kind of American economics becoming a victim of its own success, where it started with parts being interchangeable for Colt revolvers and harvesters, and a century later, people become interchangeable, right? So competing on code, in a sense, is discovering a new source of competitive advantage, and it's reversing that move from unique parts to interchangeable parts in manufacturing. When you come to people and code, I'm going to argue that you want to move back towards non-interchangeable people, which is why competing on code is essentially competing on coders. It's not really so much about process or Scrum versus waterfall. Those things are important. But my thesis is that when you want to compete on software capability as your primary competitive advantage, you're competing on people, not on processes. Okay, let's see. So this is the state of how you compete on coders today. The famous buffet lunches at places like Google in Silicon Valley. Anybody ever have one of those? Anybody been to one of the lunches at Googleplex or at Facebook or LinkedIn or places like that? Okay, so you know what I'm talking about. It's not such a common practice outside the Bay Area, but really this is the best we can come up with. You want to retain the best talent. You want those 10x software engineers, and the best you can do is load them up with stock options and fancy buffets. But this is really a Band-Aid because we haven't gotten to the heart of the psychology of software developers and really figured out what makes them tick, what makes a 10x developer a 10x developer. How can you keep that person engaged in the workplace and eager and willing to work for you? Okay, so this phrase, it's repeated like a mantra by a lot of people over process. Everybody at least pays lip service to it. But we don't really spend much time on the phrase. We kind of put it up there and then move on and start talking about process again. So today I'm going to devote the entire talk mainly to people over process and actually try and find some substance behind that. But let's put a pin in that thought for now and take a little detour towards some broader issues in software today. Everybody heard these quotes? They've been doing the rounds recently. So Mark Andreessen said, software is eating everything. And David Kirkpatrick, he's the, I forget the thing he organizes down in Austin or someplace. Well, he had this line, which I think is a really good one, which is every company is now a software company. It doesn't matter whether you're in manufacturing, oil refining, or plastics. Your competitive advantage and organizational capabilities, a lot of it is now becoming pretty much a software competency. But there's a problem there. Most software is extraordinarily crappy, right? Okay. Now, what do I mean by most software is crap? I mean something actually very specific. So since I'm now kind of putting on not so much my product manager kind of hat, but more my writer hat, I try to think of software development in terms of a narrative structure. So at its core, what you guys call an application lifecycle management process, I try and reduce it to this. Really, it's like storytelling, and the model of storytelling that's the simplest one I could find is something called the Freytag triangle. It's from 1853, a German literary researcher who looked at dramatic structure in old Greek plays and so forth, and this is the simple structure he came up with, that you have rising action and dissonance in a story, you have a peak climactic moment, and then you have falling action as the tension is resolved. This is the story of pretty much every software project if you zoom down to the primitive unit of cycling. You have rising action where you're expanding the feature set, the software can do more and more after your previous version, and at some point, most people release at the point where they think they've completed the feature set, but that's when the product managers get off the backs of the software engineers, and then the software engineers get to what they really want to do, which is refactor, lower entropy, and pay off technical debt. Anybody here not familiar with the term technical debt? Raise your hand if you're not familiar with the term. Okay, 2 people are admitting it, 3 people. Okay. So the basic idea behind technical debt is when you're evolving a software product, there's so much pressure from the customer-facing people to just get the thing out, to ship an actual working product with all the features that they want, that a lot of corners get cut. Things are done in a haphazard way. And what's propping up the features that are on the surface isn't that strong as it should be on the back, and refactoring is sort of the process by which you make the software more resilient, robust, compact, efficient. So it's like, I think of it as trash compacting. There's a lot of trash that goes into code, and then you compress it down and make it more efficient trash. But that's paying off technical debt. But there's a problem with this storyline that, you expand the feature set, release, then give your developer some breathing room to refactor and reduce the entropy. And in theory, it looks like the starting and ending points are the same. In practice, that's not true. These are the 2 trajectories that actually result. Most of the time, technical debt is accumulating in a typical complex software project much faster than it's being paid off. So each time you expand and then you refactor, you're left with a little bit more technical debt. So you're on this rising entropy trajectory. And eventually, that's your application life cycle, from birth to death, increasing entropy. And finally, the thing is such a piece of bloated crap, I keep using that term, that you have to throw it away and start again, right? And then there's the 1% of software that goes the other direction, and it truly is just 1%. When you talk to like famous software engineers, they'll say that maybe a few of the core pieces of the internet, maybe things like Donald Knuth's text processing program, those are some of the few examples of code that has actually improved over time and lowered its entropy. So if you do that, well, you get to this mythical state of eternal sunshine of immortal code that's had all its bugs squeezed out, and it can live forever in theory. And it seems like just an ideal state to have, but when you think about things like the internet, it's something that was turned on in 1979 and hasn't been turned off and will never be turned off. Immortal code is not that far off. Most code is going to have to slowly live in an environment that's at least partly immortal very soon, right? Okay, so 1%, 99%. So really, when Mark Anderson said software is eating everything, I interpret it as crap is eating everything. And I could not resist this joke. Sorry. Okay. By the way, I've been trying to experiment with this method called the Lessig method of presentation, where you just put one core idea on each slide, or one image, or one sentence, and it's working pretty well for me. This is one sentence. I can read it out if you like. Okay. So I'm going to take a deep breath here and attempt this. Software is eating the world, and every industry is being dissolved, disaggregated, disrupted, and de-engineered in an acid-rain downpour of big data and free agency, coming down from clouds that are forming via data evaporation from a world that's an ocean of sensors, iPhone and Android apps, and untamed social streams of Facebook Live. And when the Internet of Things happens, and it's all connected up into a single giant software application, well, here the story branches. There's all the singularity people who believe that some sort of virus will mutate into Skynet, and it'll become sentient and take over all the drones that people are building, and the drones are going to kill us all. And the other path, which is this whole 99% of software is crap path, is that the whole thing will collapse under its own weight, and the outcome is still the same. It's going to kill us all. Except with the singularity version, there's at least some slight hope that Skynet will turn out to be a benevolent kind of lord and master and not kill us all. But if it's all crap, it's going to kill us all. Okay. So the bigger point here is technical debt is growing faster worldwide than it is being paid off. And you can see this in every single software project. Go into any enterprise intranet, there's probably going to be some old payroll processing app that's been sort of groaning along for decades. It doesn't work anymore. It's running on some ancient version of the Java runtime environment. I was at Xerox, and our HR app was running the JRE version 1.4.2, and I had to keep that going, and it was, I wanted to get that thing off my computer, but I couldn't. Okay, so this is a hugely important topic. And there's a lot of reasons why this happens, of course, and I want to keep coming back to this point. That's why because it's so important. So one reason is, of course, that debugging is much harder than writing a program in the first place. There's a lot of other codes that make the same point. There's one that goes that if you fix a bug, 2 more bugs are going to creep in the process of fixing that bug. There's another line that goes, reading code is much harder than writing code. So these are all the reasons that make code go on that trajectory towards entropy and death. So just to break up the monotony of me talking continuously, I was going to try and make it a little interactive, and I tried to think up an interactive element here, but the only one I could come up with was I have a few copies of my book here, and I'll try and do a little Q&A for anybody who can answer one of my 3 questions that I'm going to ask. The first one, who can tell me what the ALM logo is? It has a very specific name, and it's actually very appropriate for this talk. The ALM logo, it's on your program. I'll bookmark like that, circle of life. Okay, yeah. I didn't set any rules. Nobody thought to look this up on Google, but I'll give it to you since you came closest. So it's kind of the Zen equivalent of a non-circle. It's called an enso. An enso is a Zen symbol that tries to make the opposite point that many art teachers make, that you've probably heard this. Art students are trained to draw the perfect circle, right? And many professional artists can actually draw something that you cannot tell apart from a circle drawn by a compass. And an enso is kind of a symbol that Zen monks paint as a kind of meditative practice where the focus is not so much on getting the circle perfect, but on just the meditative practice of sort of mindfully going through the circular motion in Zen art. So it doesn't look like a perfect circle, but if you're meditating properly, it should eventually become a beautiful thing. And the reason I think it's a very appropriate motif for this event and my talk in particular is, if you look at that Freytag triangle of narrative and so forth, lots of such little symbols and diagrams appear in conferences like this, but it's really the idea that you're not doing perfect repetition, either if you're doing Scrum or any other kind of cyclic process. It's not perfect repetition. It's a mindful process that creates kind of a Zen-like flow if you're doing it right. So it's not about getting the circle perfect, it's about getting the flow and mindfulness right. Okay, so that was my first question. I'll think up a couple more in a bit. Okay, so this whole idea of technical debt, entropy increasing in software, it's all going to collapse and kill us all. I'm not exaggerating. Go listen to this talk by Alan Kay. He's one of the pioneers of software engineering. He invented object-oriented programming at PARC back in the day. And he has this wonderful talk where he talks about, well, amongst other things, the number of bugs in Microsoft Office and how there's like a 10-story building worth of code and certain bugs haven't been fixed in like 20 years. And what the impact of all this is as software gets more complex, more integrated, and just simply more mission critical to life, and you can't turn it off anymore, especially with the internet. Okay, that's your first action item. Okay, let's get back to the thought I put a pin in, which is people over process. So this principle is not generally wise outside of software engineering. So manufacturing, we talked about interchangeability. That really is the heart of a lot of manufacturing industries. My dad was a TQM practitioner towards the end of his career. I grew up in a steel town, so I grew up around my dad talking about things like ISO 9000 and so forth. So people over process, it's not one of those philosophical mantras that you should repeat all over the place. It has its time and place, and software is one of the places. Another way to say people over processes, one size does not fit all, right? This again is one of those phrases that pops up, everybody talks about it, but then somehow it gets lost and then you move on. Again, you're back to block diagrams, little pyramid diagrams, and you suddenly have forgotten all about people. But let's see if we can put more substance on that. Okay. How does everybody like that thought? For Scrum, Waterfall, anything. Enlightened governance with a wise policy of exceptions and customization of processes to specific situations. Managers love to make up phrases like this, don't they? I prefer a much shorter phrase, which is just principles of forgiveness. Because if you look at that original phrase, which a lot of managers will trot out, it still sort of is like, I'm still in charge. I'm going to set a policy around this. But then you take a lightweight process like Scrum, start adding exception management layers, this codified appeal procedures, blah, blah, blah. And suddenly your one-page process description has become like a 50-page manual, including all sorts of grievance and appeals procedures. And really, you're worse off than you started. It's entropy accumulating in organizational processes that control the software. So really what I'm talking about is principles of forgiveness. Okay. So another of those bromides, right? How many of you have had a manager or have personally used the phrase, ask for forgiveness, not permission? Come on, admit it. All right. But think about it. It's completely meaningless if you always forgive or never forgive, isn't it? And that's what it ends up being. There are these hands-off managers who really are a little insecure about their technical depth and debt. They're a little insecure about whether they can actually go toe-to-toe with their software engineers and challenge them and so forth. So they're kind of in awe of their best engineers and back off and say, all right, do whatever you want. You know the best thing to do. So that's one extreme. The other extreme is the micromanaging type of manager who wants to follow processes to the letter and never forgives any transgression. It's like, all right, you switch the Scrum cycle from 2 weeks to 2.5 weeks because somebody was having a baby and the meeting needed to be rescheduled. You're out of here. Yeah, I've seen managers like that. I don't know what they're thinking, but so the two extremes are always forgive or never forgive. But really, if you believe in the principle of asking for forgiveness, not permission, it means you sometimes have to withhold it and sometimes you have to give it. So, to not be some kind of arbitrary jerk who's hated by everybody in your organization, you have to have principles of forgiveness. You don't have to write them down, but you have to sort of project a personality and a model of behavior where people start to trust your judgment about, all right, there is some rhyme and reason to the way this guy agrees to let rule breakings go and not let them go, right? So, if you get these principles of forgiveness wrong, something far worse than rule breaking will happen. All right. Anybody want to take a shot at what something far worse than rule breaking is?
Lose the respect of the team.
Any other thoughts here?
Disengagement.
Disengagement.
Where you're not really
Close.
into it.
Okay.
Resentment, a
Resentment.
revolt, a revolt,
A revolt.
rule making.
Rule making. He got it first. Well, actually, who said rule following? I'm kind of in two minds here who to give it to. Who said rule following? Okay, you came closest. It's actually rule following, but rule making gets at the same spirit. So you get perfect rule following. You turn all your staff into bureaucrats. And if you look into the history of the labor movement and industrial action, that's actually a way to do a strike. It's called work to rule, where all your workers follow your procedures and policies to the letter. They will only come in at 9, leave at 5, follow every procedure and rule to the letter, and nothing will get done. Operations will slow down to a complete crawl. So what work to rule really gets at is that a set of processes that's an organization at any given time is really always a work in progress. Your best people are always hacking away at it. They're improvising, they're flouting certain rules, they're kind of tweaking and evolving it constantly. And that's why your organization is even functioning. If they're not constantly doing that and they stop doing it, work will grind to a halt. And in software, this effect is actually 10 times stronger than in manufacturing, because there's a lot more creativity and judgment involved in software development. And the only reason software engineers at some big company haven't yet tried to do a strike based on this principle is that software engineers tend to be very individualistic and don't band together into labor unions. If they did, and a big company had all its engineers perfectly following the rules of Scrum, that would be a nightmare, or any process model. Okay, so going back to principles of forgiveness, who decides when it is okay to break which rules and why? That's going to be my, well, how many books do I have left? I have one book left. Okay, so I'll save my question for a later slide. But this is a non-prize question. Because it's simpler. Who decides when it's okay to break which rules and why?
The team itself.
The team itself.
The one who made the rule. The one who made the rule.
The one who made the rule. Often in practice, that's what happens. Oh, okay, I have another book to give out. One who's breaking the rule. Everyone. I'm looking for one word here.
I do.
Consensus.
Me. All right, I'll give it to you, everyone. Everyone, to me, is synonymous with culture. So there's two parts to any organization, right? Anybody here with a sociology degree? Jessel Shaft and Jermaine Shaft. Vague memories of Sociology 101. So there's the formal organizational structure, which is all the codified rules and processes and systems and so forth. And then there's the softer stuff that kind of is the flesh inside the skeleton. Those two parts are kind of what sociologists think of as making up the entire organization, and culture is, you can think of it as sort of infusing both in a certain way. And there's governance, and there's experts here who are going to talk to you about governance a lot more over the next couple of days. But my focus is more on culture, and I'm going to talk about a very small piece of culture, which is narrative and archetypes. So by narrative, I mean the grand narrative of a group. What is its self-image? What story or journey is it going on, right? So every subculture, big culture, country, civilization, there's usually a grand narrative. And that's sort of where members of the culture gain their sense of identity. So we'll talk about narratives within the context of software development organizations. So what you forgive depends on where you are in the story. Let's go back to this model, the Freytag triangle. So there's rising action, falling action, resolution, you live happily ever after. Kind of makes sense, right? That where you are in the story should have an effect on what you forgive and when. Okay. I made the diagram a little bit more complicated. I took Freytag's triangle and added ideas from Joseph Campbell. Anybody here not hear of Joseph Campbell? The Thousand Faces of the Hero. Okay, so Joseph Campbell was a mythologist and narrative science researcher, so to speak. He looked at the structure of folk tales and mythology around the world using the lens of Jungian psychology. And he came up with this model of, which is called the hero's journey, which is sort of the story pattern that emerges in pretty much every major heroic folktale around the world, and it's called a monomyth. And this is based on Freytag's triangle plus the monomyth. So let's walk through what a software development in between releases kind of process looks like on this diagram. I'm not going to go into detail on those labels there. They're in the book, but I'll just map them to the software process, okay? So take a typical creative team, and they start out on a challenging project with something close to playtime. They don't yet have a feel for the problem. They're talking about it, they're brainstorming, they're discussing, they're messing around. And during messing around, they may build one really crappy prototype just to get a feel for the problem. But at some point, somebody gets that aha insight where the whole thing comes together. The chief architect or whoever comes up with that insight has that flash of insight about where the conceptual integrity of the solution should lie. And at that point, you may decide to throw one away. Frederick Brooks' famous principle, plan to throw one away. So you have this messing around phase, right? Then you have the aha moment. Then you start to find your tempo. That's the title of my book. I keep sort of shilling it. Okay, so you find your tempo, but that's like find your rhythm, your cadence. How does the team chemistry really dictate how you work? You find the tempo not just of the people in the project, but the product itself. And at some point, when the rhythm is strong enough, well, that's when tools start to help. And imposing Scrum at this point is a very useful thing to do. And I like to compare this process to actually improv music, especially Indian music, where there's an extended expository phase where the drums don't kick in, where the musician is just exploring notes and playing with them. But at some point, when the musician gets an idea of what the improv piece is going to be about, the piece starts to gain some structure, and at some point, when there's enough structure, the drums kick in. So that's the part where Scrum starts to kick in. And at some point, where the valley portion ends and the upslope starts again, I think of that as sort of the encounter with the monster. There's this idea in Joseph Campbell's monomyth that the hero goes into some dark cave and slays some monster, and that's the point at which the hero really finds his identity and is ready to take on his real-world enemies. So in the story of Medusa, for example, it's the slaying of Medusa. So there's some sort of key psychological moment where the team kind of finally realizes, all right, now we can do the big push. And there's the upslope, which I call the heavy lift in the previous slide, where people say, the hell with process, I'm in the zone now, I don't need all that scaffolding, I'm going to just power through and get this done. And at this point, processes usually do fall apart because people are just working so hard that the process becomes unnecessary. They're like training wheels that can come off for a while. And then you do the release, then retreat and refactor, and back to playtime. Right? So this is what I call forgivable sloppiness. At each phase, you have to look at the narrative structure. For example, don't insist on developers using Scrum during playtime when they're just trying to figure out the idea and get a feel for what the product should be like. If there's a heavy lift coming up, the product has to ship in 1 week, and everybody's in the zone and charging ahead. A Scrum meeting might actually be a waste of time. Throw it out. Okay. But again, I want to caution you, going back to that sort of fake managerial quote about, exceptions, blah, blah, blah. There's a strong temptation to take such narrative structure ideas from literary theory and turn them into yet more formulas, where you say that, all right, this is going to be the phase structure of the project, the exploratory phase, the execution phase, and these are the exceptions that are allowed in each phase. You're back to square one. Really what I'm talking about is narrative situation awareness. You really have to be in the story, acting in the story, know where it is, where it's going. That's where good judgment comes from, in my opinion. Okay. Stories have plots, and stories have characters, right? We took a look at narrative, which would be the plot element. So let's take a look at characters. And writers and dramatists typically think in terms of archetypes, characters that have a very universal kind of personality. So in Jungian psychology, there are certain key archetypes that lead to, for example, the Myers-Briggs personality test. So archetypes are very important in writing good stories. And going back to principles of forgiveness, what you forgive depends on who you're dealing with. Now, a lot of people react very, very badly to this idea. It seems unfair, doesn't it? There should be one policy for everybody, nobody gets a free pass. The very idea that who you are determines what you can get away with, it sort of smacks of favoritism, nepotism, and self-absorbed celebrity star cultures where some 10x ninja rock star programmer thinks he can do anything he likes. But there's a reason in practice that's what happens, because really, when you're actually trying to get things done, you do have to take personality into account. So again, I like to think with as big a historical context as I can. And today, in the beginning of the 21st century, we are living in a world that, as Mark Anderson said, software is eating everything. So a lot of our work archetypes revolve around the world of software. That's a famous rhyme from the 13th century. 13? Yeah, it was, I think, first documented in the 13th century. But that's what little kids used to sing. Did you guys watch the movie, the Tinker Tailor Soldier Spy? That comes from this rhyme. So this was the world until 1999 or so. Then software started eating everything. And today we have all these sort of unfamiliar new types of workers. There aren't really university degrees and so forth around this. This is like, it's so new that the education system hasn't really caught up with it. But these are the terms in which software engineering culture thinks. Hackers, hustlers, coders, admins. Well, money man is still always important. Rich man became money man. Data man, UX man. Thieves like to call themselves consultants these days. Anybody want to give me a watch? I'll tell you the time. Okay. So how do you start developing a good sense of how to think with archetypes around software development subcultures, right? And the best guide to archetypes in the world of software is actually software culture itself. What do you know about really geeky, extraordinary software engineers? They love science fiction, they love fantasy, right? They love all these intricate worlds where very complicated things happen. Like two of the best programmers I ever knew, they were huge fans of the show Lost. I got lost with Lost in like 3 episodes, and I was like, I don't have time for this. I'm not following this intricate plot with millions of people doing millions of things. But the software people loved it. They play Go, they play chess. Many of them are into martial arts, right? And I think Neil Stephenson really nailed it. This is quite old, actually, 1999. But really, contemporary software culture, it's really a divide between those who know how the world works and those who don't. So there are people who are in the software management and technology management business who come from liberal arts backgrounds and so forth and sort of pick up a lot of things. But honestly, if you haven't dived into the bowels of technology and really sort of half turned your brain into a piece of technology itself, you really don't get how the technology world works, and it's okay to admit that. So these are the Morlocks. They are the people who know what the configure worm does and how it breaks through security systems, right? They're the people you turn to when you realize that there's this obscure problem with your entire software system that nobody else knows how to figure out. So these are the Morlocks. I'll give you a second to read that quote, and then I'm going to ask my third and last question for my own book. What was the relationship between the Morlocks and the Eloi? There you go. Morlocks used to eat the Eloi. So Morlocks in H.G. Wells' novel were these underground dwellers who kind of fed the Eloi, the sort of fed upper class world that really was basically useless except as food. We're almost getting there, except as Neil Stephenson points out, the Morlocks are not like a huge subspecies living underground. It's actually a very small minority. It goes back to the 199 ratio. I would say amongst technologists, this is all software engineers and other kinds of engineers, there's really only about 1% of people who really grok technology at a very deep level, right? So let's turn to software culture in terms of its own archetypes and examine some of the kinds of people you might encounter as a manager doing application lifecycle management. Anybody ever met a dwarf? Their entire life philosophy is beauty. These are the people, typically they love Ruby, for example, because Ruby is a language that people who love it think it comes close to poetry. There's like a comic book about it that says it's called A Poignant Guide to Ruby, which is like a comic book with a fox as its lead character, and it gets into how Ruby is the most poetic language ever. And one of the chief architect of one of the products I developed at Xerox, he was a classic dwarf. He even had a long beard. And he loved Ruby. He was always looking for beauty in everything. And you don't know the cost you're paying if you ever throw an ugly thing at these people. They will completely disengage and leave. So next time you want to throw a complex process slide up on the screen, be careful who's listening. Then there's wizards. So a lot of software engineers are extraordinarily smart people, and they can outthink most of the managers they report to, but they don't like management, so they don't get into it. But if you actually get delusions that you're in charge, and you try to cross them, and they take a stand, you'll realize pretty quickly that you're not. Because these are irreplaceable linchpin type people, and they know they've got you in a position where they can basically blackmail you to accept their design philosophy. And the only sort of mitigating factor to the existence of wizards is that they're usually right. If they're wrong, fire them. But usually, if a wizard sort of digs their heels in, they're right. I met my first wizard, I think, in 2000, and I thought he was kind of letting me run the show. I was doing user experience design for a bunch of web services, and he was kind of nice and smiling and basically letting my designs go through to the coders as they were. But at one point, I did a design that he hated, and he refused to let it move forward until it got changed to the one he wanted. And I fought with him a lot at the time, but a month later, I had to admit he was right. Okay. Anybody ever have this experience where you've just recruited a really smart software engineer to your team, and you're explaining what you want them to do? In this case, the example I'm thinking of, I just did a paper napkin sketch of a little feature I wanted. And this guy, true ninja, solves the Rubik's Cube in like 40 seconds flat, no matter where it's at. He understood my idea like 10 times better than I myself understood it, overruled me on half the design ideas that I had put in, and then went ahead and built it so much better than I'd ever imagined that it kind of made me sit back and realize that whenever I meet somebody like this, I got to grab them and hold on, and then let them overrule me whenever they say so. So in Japanese culture, by the way, ninjas and samurai are kind of opposites in some sense. Samurai kind of are on the field, out there warriors who fight very openly and honorably, and ninjas are kind of the special ops forces who kind of fight in the dark. But samurai type people, they may work for an organization, they may have signed a labor contract where they say, I work for Microsoft or Google or whatever, but their loyalties are primarily to people. Their loyalties are so extraordinarily strong that you should be scared of it, because if their loyalty ever flips to hating you, you're in deep trouble, because they're in the organization accepting your paychecks because of you personally. And if they decide they don't like you and leave, your entire project can come to a halt. So you have to make sure you never stop fighting for them within the organization. And finally, there's elves. By the way, I should credit Neil Stephenson again. A lot of this is borrowed from Cryptonomicon. Everybody read Cryptonomicon? Who has not read Cryptonomicon? You guys are a software dev. Learn the people you're working with. That book is like, it gets at the heart of self-conceptions and perceptions in the software engineering world, and you really need to get inside their heads. I mean, you're trying to get the best out of these true rockstar 10x type people. I mean, there's people who are skeptical that 10x people exist, but I've met them, I know they exist. You have to get inside their heads. But elves are people who understand computer science and stuff related to it at such a deep level that you don't even know what questions to ask around those kinds of issues. So a classic example is the P equal to NP kind of deeply theoretical idea. And most technology managers have only a vague idea of what P not equal to NP really means, if they're from a non-technical background. And quite often they think up problems where if you really dig and dig, you'll find that at heart you're asking for something that's theoretically impossible, and there's $1 million prize associated with showing that it's theoretically impossible. That's the P equal to NP theory conjecture. But these are people who actually understand this stuff at a very deep level, and you got to let them be, because if you don't understand what they're doing, how are you going to manage them? So all these types of people, depending on personality, you're going to let certain things go in your process management philosophy. And if you try and abstract sort of a general principle from all this, the exceptional nature of software culture arises from the fact that software engineers build their own tools, which is why software tool sets are changing so rapidly, because the moment a software engineer finds like a flaw in something and decides that they want to improve it, they'll go and build a better tool, right? Which makes them more like the old school guilds before mass manufacturing came in, which means you really have to look at 1800s, early 1800s workforce culture to understand what workplaces that are guild-like look like. So that's my book. That's your second action item. Read it. Okay. So I've spent a lot of time pandering to software engineers' egos in the last 10 minutes. But that was the post that got Chad to invite me here. There was a post I did called The Rise of Developeronomics. That's a horribly hard word to say. It got slash-dotted, and a lot of software engineers loved it because I was praising them. But there's the other side, which is that, well, they have their own little subculture, but you do have goals. You want to make a profit and so forth. So let's switch to the bad cop, evil manipulation part. So the one ring to rule them all. Software engineers are smart, highly individualistic people who understand most things better than you ever will. They will push back and refuse to do things if they don't like it. As a manager, the worst thing you can hear is an outright and flat no from a very talented person you don't want to lose, because you have no choice. You can't react to a very firm and unambiguous no, right? My experience has been that the only real way to manage software developers effectively is data. And I'm not going to say too much about that. I'll just hint at how data fits into this whole picture via this quote. I love this quote. When art critics get together, they talk about form and structure and meaning. When artists get together, they talk about where you can buy cheap turpentine. Right? So software developers are artists, the good ones at least, not the interchangeable second-tier ones that we heard about in the first talk. The 10x ones really are like artists. Paul Graham has a great article called Hackers and Painters, if you're interested in exploring the thought. But because they're artists, they're susceptible to what I call the turpentine effect, which means that if they don't have real-world data to work with, most of them will start building tools. They'll start painting their own little holder of brushes and things like that. Look, think about all the great programmers you've heard of, right? What's Linus Torvalds most famous for? Git, right? Everybody here are familiar with Git? Okay. So yeah, he did Linux, but in my opinion, in history, he's going to be remembered for doing Git, which is a version control system. There's Joel Spolsky, who writes the Spolsky on Software blog, excellent blog, and he's also the founder of Fog Creek Software. What does that company do? It builds tools for developers. So software developers don't really pay attention to the external world, which means their weak spot is real-world data. If they don't have support from non-software engineers, what they end up doing is building software tools, more and more software tools. Like the 10x ninja kind of guy I told you about who solves the Rubik's Cube in 40 seconds flat, I once asked him what he would do if I basically gave him 6 months off to build whatever software he wanted. And he said he would build this test framework for where people could do software, do usability testing, and then upload their own videos to a site where you could do test management. I was like, ugh, I would never think of such an idea. But try this out. Next time you meet a really smart developer, ask them what they would do if they gave them 6 months off. I'm betting that most of them will pick some sort of software tool. But that leaves form and structure and meaning to the rest of us, right? So what are we building? Why does it have the particular shape it does? How should we structure it? What does the software mean? What does Microsoft Excel mean? How does it fit into the real world? And here, this is my third and last action item. And honestly, if you're going to only buy one book or do one thing as a result of this talk, I would recommend this book over my own, Seeing Like a State. It's a prize-winning political science book by James Scott. He's at Yale now. And the subtitle is what I want to get at. It is How Certain Schemes to Improve the Human Condition Have Failed. Let me explain that in this. OK. So So what Scott did was examine a huge number of examples from political science of various governance schemes, and he found that they often failed through a process he called thin simplification, which is you take something like a natural forest, wild forest, trees growing haphazardly all over the place, different species. You don't really know how that ecosystem is delicately balanced and all the different things it does for the surrounding human and animal communities. You come in from the capital city and say you want to increase lumber output by 15% in the next fiscal year so that government tax revenues go up. You realize that certain trees are the highest yielding varieties, and you want to sort of replant the entire forest with those trees. You plant them in neat rows. What happens? Things tend to fall apart extremely fast. In this particular specific example, these kinds of monoculture forests are very susceptible to diseases that spread through one species, right? So they're very fragile. They're not robust. And Scott came up with this beautiful concept called legibility, which is when a central planner, which could be an application lifecycle development manager type person, looks at a complex reality, like say an ecosystem of developers and code that seems to be doing some mysterious things and somehow making the company money, there's a tendency to see it in very simple ways in terms of a few metrics, like say, all right, we are developing this product that has this gross margin and so forth, and see it only through that lens, and then comes the crucial mistake. You simplify that organic reality down to the point where it conforms to your much simpler thin simplification. The whole thing becomes less robust, and your entire subculture falls apart. This happens in urban planning, where there's centrally planned cities with neatly laid out grids and so forth. They become unlivable. There's no downtown culture. So the failure mode of thin simplification as applied to software is thinking of it purely in terms of business goals. When you really look at a thriving, rich software engineering culture, it's a lot more than an entity that produces certain software applications and earns you money. It's also a mentorship system. It's an apprenticeship system. It's a tool-building culture. A software product that your company may build may become a complete failure and not earn you any money at all, but it may lead to the development of certain tool chain pieces that are then released open source and suddenly become part of the broader culture and make an invaluable contribution, right? So all these little invisible things you don't actually know until you're actually inside the subculture. So don't kill the golden goose. If you don't understand it, don't assume it's useless noise. It's not there for you to rationalize and reduce to a thin and orderly world, which will actually do your bidding, because if you do that, it'll become fragile and break. So what James Scott calls this kind of knowledge, the kind of knowledge that cannot be captured within what he calls epistemic systems, which can be codified in things like application lifecycle management, best practices, all those things. That's epistemic knowledge, but that covers only a small part. The rest is what he calls metis. So metis, I don't know actually how to pronounce that. It's an old Greek term for workmanship. It's the kind of knowledge that's passed on through apprenticeship and lives within a culture. And if you try to sort of capture it outside of people's heads, you'll invariably end up with like sort of a thin simplification and not get it all, and you'll end up failing. The key is similar but not identical tasks. Going back to the idea that one size does not fit all. Every software project is unique. It has a unique story. It has a unique cast of characters. You have to customize and so forth with principles of forgiveness. Think in terms of the emblem of the end zone, not a circle. It's like this little hand-drawn mindful management motif. If you do that, you've got metis. And of course, great programmers form a subculture based on metis. And you have to respect it. Especially the parts that you don't understand. Don't assume that the parts you don't understand are useless or noise. But it's a mistake to respect it too much. So there's this meme doing the rounds, and Tony Hsieh of Zappos is the guy responsible for it, where it's all about culture and senior management and executives just forget about strategy and competitive advantage and where your unfair advantage comes from. And it's all about just build a great culture and strategy will take care of itself. this is going too far. Because what happens if you allow that path to go all the way and become the company culture? Well, the subculture of metis and positive self-images, this archetypes of druids and wizards and dwarves, that sort of becomes a culture of self-congratulation. It turns into insularity, and at some level, it turns into complacency. So I'm just going to leave you with a few thoughts on this first part of my talk, which is breathing data and how that fits in here. These are pretty old ideas. They're from the 1960s, but they're hugely relevant to software engineering today. Has everybody heard this law, Conway's law? All right, another moment of admission. Who has not heard of Conway's law? All right, so this is from 1968, where Conway actually did some studies of many organizations and found that software architecture tended to mimic organizational architecture. So in open source, for example, the version is that if you've got 4 teams working on a compiler, you'll get a 4-pass compiler. So organization structure sets a template of communication patterns that shows up in product architecture. And Conway's law has been sort of validated by significant research, including a couple of papers from Microsoft Research. So this is actually one piece of how, when you don't have data to actually build products informed by data, you end up sort of having these mirroring effects where organizational structure ends up dictating product structure instead of the actual use cases and so forth. And a related quote is that structure follows strategy. This is, again, an old idea from the 1960s. Modern strategy theory from the likes of Michael Porter does not actually follow this kind of thinking. But this was Alfred Chandler studied, I think, like over 100 organizations and showed how the organizational structure, the structure of divisions, and whether it was vertically integrated or horizontally integrated and so forth, it followed from the strategy. But then, unfortunately, a bad thing happens. Once the visionaries leave, strategy starts following structure. But tying it back to the idea I started with, when software eats everything and every company is a software company, strategy starts following data. And we've come a long way in sort of developing this idea. Nick Carr in 2003 wrote this influential article called IT Doesn't Matter, where he argued that IT is not a competitive advantage. And a lot of people since then have been trying to figure out how to argue that it is. I'm one of the people who believes that it is, if you do it right. And competing on analytics, that's a book by Davenport and Harris, good book if you haven't read it. If you try and build competitive strategy on code alone, you're going to fail. But combine code and data, you've got a foundation on which you can build corporate strategy. So managing metis means mastering data. And this is sort of the chain of reasoning that sort of summarizes what I wanted this talk to convey. If your company is breathing data at every level, it's going to inform strategy and make it better. If the strategy is better, the structure is going to be better. If the structure is better, then the subculture that lives within it, so the Gemeinschaft, Gesellschaft distinction, that's going to be better. A richer subculture is going to lead to better code. Better code means better company, because every company is a software company now. And if you're a better company, you're going to be able to eat your competition instead of being eaten. I'll leave that last slide up there. 3 action items. Seriously, listen to that Alan Kay talk. It's kind of like a horror movie about where software is headed, and don't wait for Halloween, though. And these 2 other books. All right, then I'll stop. Take any questions?
So I assume there's going to be a few questions on that presentation. It's very inspiring. Any questions from over here?
So, so is there any process to follow, or you have to be like out of the problem? What is your
My sort of one-liner answer to that question is, you should believe in a process, whatever process works for you, enough that it allows you to move forward, but be skeptical enough of it and be ready to hack at it. So don't make it a religious thing. Just allow it to become sort of a hackable process.
Any other questions? How many people here have ever seen a presentation like this before where it's incorporating so many different elements?
Actually, I have a question. Something that you mentioned in the beginning about the perpetual growth of technical debt. And I'm wondering if you look at consider it from a perspective where maybe it doesn't really matter because a lot of the software systems, especially in business, have limited lifetime. So the technical debt grows perpetually, but then why not? Lifetime of the system.
Yeah. That's actually a very fascinating question. So if I may summarize it, it's, well, many of these business systems, they're in companies that are not going to be around forever, for example, and why should you even care about immortal code? Well, one part of the answer is just the technical ecosystem. The internet is one giant connected software application in a sense. So we are getting into a culture of immortality. But the other part of the answer actually has to do with questioning the assumption that companies should not live forever. So there's some very interesting research going on recently in this area. The oldest continuously operating business in the world was a Japanese builder of Buddhist temples called Kongo-gumi. It was founded in 542 AD, I think, and it just went under like 10 years ago. Some sort of financial bankruptcy thing, so like 1,500 years. And in the last 100 years, company life cycles have been really radically shortening. So this was in a book called Creative Destruction by David Foster. The companies in the S&P 500, their average lifespan of existence has come down by about 33% in the last 50 years or so. So a big mega trend going on is that company life cycles are getting shorter and shorter because the model of competition we've come up with has become unsustainable, right? And that's partly because companies are only able to live as long as the product life cycle. They get so dependent on one product and cannot deal with disruption that when that product hits end of life, the company starts to go under because they're too dependent on it. So Microsoft, for example, it's the Office suite, and they're trying to make SharePoint a new cash cow, but it's still very heavily dependent on that one product. If that goes under, the company will go under. And now that every company is a software company, typically it's a software piece of the puzzle that determines corporate life cycle. So to get back to your question, you have to ask which way the causation goes. Is it product life cycle that determines corporate life cycle, or the other way around? Can companies live forever and continually renew their markets as old opportunities run out? And what does software have to do with that equation? Can you build software that allows you to do that, live forever?
I don't necessarily have a question so much as perhaps maybe a comment on the last question. I think it goes beyond just software living forever, at least in my team. It gets back to the culture of the team and the engagement of your team. And so if the focus is on just do it quick, get it out the door, you're reducing the engagement of your team. So like you said in the presentation, good software engineers care about what they're doing and how they're doing it. And they're not so much focused on what the business cares about. And so if you take that away from them, you're reducing their engagement and then their willingness to participate in future projects for you.
Yep. This whole thing of software engineers, good ones, really seeking beauty. I made that a particular archetype, the dwarf, but actually every software engineer that I've ever respected has kind of this instinct for beauty, and letting too much technical debt accumulate sort of really offends their life aesthetic. You get disengagement as a result, yeah. One question over there.
So, last question, just because we're about to have lunch.
Is
sort of fascinated with the concept of technical debt, and one of the questions I have is, do you see sort of implicit costs in that technical debt? I know you touched on it with the disengagement with the developers, but do you also see some type of maybe even opportunity cost or implicit costs that are incurred with that?
Yeah. So the question was, are there sort of costs associated with technical debt? And I took a shot at framing this when I was sort of coming off my last project at Xerox. We'd just gone through a major release, and there was a huge backlog. We were using Scrum at that point. And just for my own sort of sanity, I divided the backlog items into 3 buckets. I called one of them stabilize, which is stabilize the current release so that it doesn't gain entropy and go away. So that's where a bulk of the refactoring happens. The second bucket was evolve, which is these minor enhancements to the current version, which would sort of keep up with the times, so to speak. And then the third bucket I called jump, which is just go to a whole new paradigm and sort of renew the life of your software product, right? And one of the things I noticed is this coupling between the 3 buckets. So if you let the stabilized bucket get too big, there's so much entropy in the base that the evolve bucket starts to slow down, right? And at some point, jump, which is the third bucket of creating the really new, which kind of is like a nice to have future blue sky visioning product, it starts becoming, it's the only clean bucket left that even though you didn't intend for that to happen, everybody starts working on that because the rest is kind of so crappy. So if you don't manage these 3 things well, your decision-making authority is going to get taken away from you because you're not stabilizing the product well. Feature enhancements are going to become more difficult. Your product architecture updates are going to be driven by entropy rather than planning. So all those things start to become harder.